Hello friends, welcome to my YouTube channel. In this video, I'm going to share with you about another kind of water quality index method of calculation, and that is the National Sanitation Foundation Water Quality Index, or in short, the NSFWQI method of calculation. But before we start, let us quickly see in short what is water quality index and why it is used. Water Quality Index was first developed by Horton in 1965. And in general, the objective of any water quality index method of calculation is to convert the complex water analytical data or results into information that is easily understandable by the general public. Are you confused? Don't be. I'll use example to clarify it for you. Okay? So, for easy understanding, let's say we want to find out or know about the quality of water from these three different groundwater sources. So, to get the information about this same, first we collect the groundwater samples from these three different sources, and then we analyze the water samples in the lab. However, the analytical result or data obtained is not easily understandable to any non-expert in this field. But with the help of water quality index method of calculation, the analytical data of multiple parameters incorporated in the study are merged and summarized into a single value, and this value will represent the type of water quality, okay, such as the groundwater sources was found to possess either excellent water quality or good water quality, moderate or poor water quality, or maybe even the water might be unfit for consumption purposes. Till date, there are a number of water quality index calculation method developed. The list of a few water quality index calculation method are displayed on the screen. For your information, I have already uploaded videos on the first three water quality index method of calculation. And if you are interested, you can check the link given in the description below. Now in this video, we will focus on the National Sanitation Foundation Water Quality Index. However, to familiarize yourself with this method, first you need to understand these three vital and integral part of this method clearly. That is, which water parameters are incorporated in this method, what are rating curves, and what are the assigned weightage or the weight factors for each of the parameters. If these are not clear to you, then the calculation procedure will not clear to you at all. Now, let us go into the step-by-step process in order to understand the NSF Water Quality Index. So to start with, let's see how NSF Water Quality Index was developed, and most importantly, how the water parameters incorporated in these methods were selected. First of all, NSF Water Quality Index was developed in 1971 by Brown et al. And in collaboration with the National Sanitation Foundation, which is an international organization in the United States of America. And that's how the name of the Water Quality Index was developed. So during the initial phase of the development of this Water Quality Index method, what happened is Mr. Brown identified and select 142 experts who are basically water quality monitoring and assessment professionals. Okay, and in the first phase, he asked them to select 35 water parameters which they individually think should be incorporated in the upcoming and under construction NSF Water Quality Index at that point of time. And in the second phase, he again asked them to add another 9 more parameters that should be incorporated in this method. Then, after the 142 experts responded and provided Mr. Brown the 44 list of water quality parameters that they think should be incorporated in the NSF Water Quality Index, then in the third phase, Mr. Brown asked all of them to select only 15 water quality parameters out of the 44 water quality parameters that they have listed initially. So after receiving the 15 different water quality parameters selected for the final inclusion in the NSF Water Quality Index by the 142 expert, Mr. Brown finally select 9 parameters of the 15 to which will be incorporated in the NSF Water Quality Index method of calculation. And these 9 water quality parameters are dissolved oxygen, fecal coliform, pH, biological oxygen demand, nitrate, phosphate, water temperature, turbidity, and total dissolved solids. So with this, from now on, remember that if you're dealing with NSF Water Quality Index, the only water quality parameters incorporated are these 9 water parameters. Okay, so NSFWQI is equal to 9 water quality parameters, and these 9 water quality parameters are the one displayed on the screen. Next, once the 9 parameters have been selected for incorporation in the NSF Water Quality Index method of calculation, next step is the development of the rating curves. What Mr. Brown did was he followed the same procedure like he did in the earlier case. What he did was he asked all the 142 experts to prepare separate rating curves using plain graph paper for all 9 parameters that are incorporated in the NSF Water Quality Index method. And in the same way, all the 142 experts did what they were asked to do. That is, they prepared a rating curve for all the 9 parameters. After that, Mr. Brown used the rating curve prepared by all the 142 experts for all 9 parameters and developed the final rating curves. So the NSF Water Quality Index rating curve for all the 9 selected parameters are displayed on the screen. Now remember that using the rating curves, the Q value or the sub-index value of all the 9 parameters can be obtained. I will show you in a while how to get the Q value from this rating curve for different parameters. Okay, but before I'll show you the tutorial on that, we need to understand about the third integral part of NSFWQI, that is the weight factor. And to come to that first, this is the formula for calculating the NSF Water Quality Index method. That is, NSF Quality Index method is equal to summation of QI by WI, where WI stands for the weight factors for the ith parameters, and the summation of WI will always or equal to 1. And QI is the Q value or the sub-index value of the ith parameters, and this value will be obtained from the rating curves. So from here, QI values and N is known, but what is not known to you is the WI value. So what is this WI? WI stands for the weight factors, which is the third important and integral part of NSF Water Quality Index method. The weight factor value or WI value assigned to the selected 9 parameters incorporated in NSF Water Quality Index is given in the table on the screen. You'll find that DO has the highest assigned weight factor, that is 0.17, and turbidity and total dissolved solids has the lowest, which is 0.08. But you might think or ask, how come? and where these values come from, or how the values are assigned to these 9 respective parameters. The answer is, when this method was developed, Mr. Brown asked all the 142 experts to rate the selected 9 parameters from 1 to 5 scale, with scale 1 indicating the highest significant parameters and scale 5 indicating lowest significant parameters. Example, like the table given on the screen. Then all the 142 different experts will give different ratings for different parameters. So when they did, Mr. Brown take the average mean value of each parameters, and then after that he converted them these values into a temporary weight value. Okay, then the temporary weight value of all the respective 9 parameters are summed together to obtain the mean value of the temporary weight value, and then the temporary weight value of all the respective 9 parameters are then divided by the sum value of temporary weight, and this is how they arrive at assigning the weight factor for all the 9 parameters incorporated in the NSF water quality index method of calculation. Point to remember is the WI, or the weight value, or the weight factor value for NSFWQI, was assigned to all the 9 parameters at the time this method was developed. Okay, so these values here were assigned right from the time when the NSFWQI method was developed. Next, according to the NSF water quality ratings, the NSF water quality index rating range from 0 to 100, and it is further classified into 5 different classes, where the rating state starting from 0 to 25 indicates the very poor water quality, 26 to 50 indicating poor water quality, 51 to 70 indicate moderate quality, 71 to 90 indicate good water quality, and 91 to 100 index value indicate excellent water quality. Now we have seen and understand from the inception and how the various integral part of NSF water quality index are derived. Now let us do the calculation part. To do so, first let us, for example, use these hypothetical data displayed on the screen as the water analytical data or water samples collected from 2 different sites, that is site 1 and site 2. So let's just assume that this is the, from site 1 the dissolved oxygen is 5.25, from site 2 is 7.91, and similarly it goes for all the 8 other parameters. Now if you remember, according to the formula, water quality index for NSFWQI is equal to summation of WI by QI. So we already have the WI values for all the selected parameters. So the only thing we have to find is the Q value, or the sub-index value, for all the 9 parameters from the rating curves using the hypothetical analytical data. Then only WI QI calculation will be complete. Okay, so to obtain the Q values from the hypothetical analytical data, I will be using this format in this tutorial for to show you how to obtain the Q value for the any parameters. So to begin with, first let us find out the Q value for pH of both site 1 and site 2. So site 1 pH is 4.6, and for site 2 is 7.6. Just cross check. See, pH is 4.6 and 7.6. So the mean pH value for site 1 is 4.6 and for site 2 is 7.6. So to obtain the Q value, I'll be using the red lines, okay, to find where the water parameters value, but that is the pH value, along the x-axis intersect with the curve on the graph, and at what point it touches the y-axis. And then only the Q value will be obtained. So for site 1, 4.6 is somewhere here. So this is the point where the pH value at 4.6 touches the curve. From here, draw a horizontal line to find the Q value. And this is the point where it touches the curve. So from here, you'll get what is the Q value. The Q value will be 18. Okay. So similarly, we'll find out for the mean value of pH is 7.6. So for at 7.6, what will be the Q value? This is how. So 7.6 is 2, 3, 4, 5, 6. 7.6 will be somewhere here. So we draw a line from here, somewhere here. So and then you draw it. This is where it touches the y-axis. So now see, so around 91. So the Q value will be 91. Okay, so now for pH, we have obtained the Q value for both site 1 and site 2. The next thing you need to remember is, in case if the pH value of your samples is less than 2 or greater than 5, remember your Q value will be 0. Alright, next for fecal coliform. So the reading here is for site 1 is 205 and for site 2 is 95. So let's cross check. See, fecal coliform, site 1 is 205 and site 2 is 9.5. So here, so similarly, I'll use the red line. So 205 is the value. So 205 will be somewhere. See 10, 1, 10, 20, so 2, 200 somewhere here. So here, so this is where you'll put the red lines, and then this is the point where it interacts. So your Q value will be around 33. So here you type 33. See? Similarly, 9.5. 9.5 will be, see, 1, 10, 5 here. So 9 will be somewhere here. Just put a line here, draw a line here. So it will be somewhere here. See? And at this point, you see it's somewhere around 74. Similarly, here also, if your value is greater than 100,000, then Q value will be equal to 2. So the same pattern we do for BOD. Okay, biological oxygen demand 5.28 is the for site 1. So 5.28 will be somewhere here. So just draw a line, straight line up there where till it touches the curve, and then you'll find that somewhere here is around 50. So you write down the Q value as 50. And for site 2, 2.57, 2 will be somewhere here. So the Q value will be 70. Okay. Similarly, here also you have to remember, if in case your reading is greater than 30, then your Q value will be equal to 2. For nitrates, 35. 35 will be 10, 20, 30, 35. It touches the line somewhere here. So your Q value will be around 21, 22. Okay. So we read it 22 here. And for site 2 is 0.4, 0.67, 0.4 will be somewhere here. So the value would be 75. Similarly, you have to remember this, if pH is greater than 100, Q will be to 1. Okay, these are all given right at the time when this method was, or rating curve was developed. For phosphorus, 3.95, 3.95 will be somewhere here. Okay, you get 17, so 17 will be your Q value. 0.52, so the reading will be somewhere around 57. And if the value for phosphate is greater than 10, then you'll give the Q value as 2.0. Next, for turbidity, 17.15 for side 1, so 17 will be somewhere here. Find where is the point at it touches the curve, and that is the point. You draw an horizontal line, and then you get the value of the subindex value or the Q value. So for side 1, the Q value is 65. Similarly, for side 2, 3 will be somewhere here. So you'll get the Q value as 87. Okay, just follow the same procedure for all. Here, if the turbidity is greater than 100, you get the Q value as 5. And for total dissolved solids, 415 is for site 1. So 415 will be somewhere here. So this is where it touch the curve. So you draw a horizontal line, and then the value you get on the y-axis will give you the Q values. And for site 2, it's 66.37 is the TDS value. So somewhere here. So your Q value will be around 87. And you have to remember, if your TDS value is greater than 50, your Q value will be equal to 20. And water temperature, similarly, for site 1, it's around 20. So your Q value will be around 21. And 13 will be here for site 2. 13 or somewhere here. See? So the value will be equal to 32. Last but not the least is for dissolved oxygen. Unlike the other 8 parameters, dissolved oxygen analytical data is expressed in milligram per liter. But this has to be converted into percentage saturation, and this can be done by using this standard convertible scale, and this is possible provided the water temperature is known. Okay, so you've seen here the water temperature for site 1 is 20.25, 20.25 somewhere here, and the DO value is in ppm or mg per liter, same, be somewhere here. So the percentage saturation will be around 57, 58. See, it will be here, the meeting point. You draw this line here, so this will be your saturation or DO percentage saturation. So it will be somewhere here. So now if it is around 55, 58, so here we 60, 58 will be somewhere here, 20, 40, 50 will be here, 58 will be somewhere here. Now you draw a line in this and see where does it touch. So it touch somewhere here, you see. So which this will indicate that your Q value will be 50. Okay, similarly, now for site 2, 13.9, 13.9 is somewhere here, 10, 11, 12, 13, 13.9 somewhere here. Okay, and then the DO is 7, 7.9, so somewhere here. So see, so the percentage saturation will be the point where it cuts the line here. So around 60, 65, this 70, 60, 70, around 71. So 71 percentage saturation is equal to 71. So it will be 20, 40, 60, 71 will be somewhere here. And you'll see that it touches the line here. So the value, the Q value will be equal to 71. And then here, in case if the percentage saturation is greater than 140, then the Q value will be equal to 50. Okay, so now the Q value of all the 9 parameters is being obtained. Okay, and to complete the calculation of for NSFWQI, let's transfer the Q value from here to the Excel sheet. So let's go to Excel sheet now. So in the Excel sheet, so for site 1 and site 2, these are the hypothetical analytical data. Okay, now the Q value we have already obtained are been placed here. Okay, for all the different parameters for site 1 and site 2. And now let's copy the Q value for site 1 first. Okay, so Q value, let's go to the working sheet. Okay, now see, we have already have, according to formula, summation of n is equal to Wi by Qi. So we already have the Wi here, see, and Qi is, will instead for site 1 is here. All right, so check for dissolved oxygen is 50 for site 1. For turbidity is 65. So similarly, turbidity will be 65. Okay, so now this, according to the formula, summation of WIQI, this will be, you'll get like this. So WI is 0.17 into QI. Okay, so I just do this, 8.5 will be for dissolved oxygen. Now what you do is you drag for all, and that's how we get. And now you do the summation of WIQI, the total. So what you do is click here, go to auto sum, summation of from here, dissolve oxygen for all the 9 parameters. Okay, so the summation of WIQI value for site 1 is equal to 35.33. Okay, 35.33. And for similarly, I'll do the same process of calculation, and to make it quick, I've already done it earlier. So for site 2, D, after putting the Q value here, then WI into QI, you multiply, you'll get this value, and then you sum, you get 71.41. So 71.41 is for site 2, and 35.533 is for site 1. Okay, now see the index value for site 1 and site 2. What is the index value we just calculated just now? The index value is equal to 35.33 and 71.41. So now see from here, 35.33, where is 35.33? So 35.33 will be somewhere here, in between this index value here. So this would indicate that from site 1, the water quality is poor in nature. Whereas for 71.45 will be here. 71.45 will be somewhere here. So in this index value, this will indicate that the water quality from site 2 is good water quality. Now, comparatively, if you see the water analytical data from site 1 and site 2, this will be quite uneasy for understanding to any of the general public. But if you look by using water quality index calculation, now I can just say that site 1 is a good poor water quality and site 2 is a good water quality, which is very easy to understand to one and all. See, so this is the benefit of using a water quality index method. So just remember that NSFWQI is a combination, is a contribution made by Brown et al. And the 142 experts. So with this, we have come to an end of this video, and these are the references used for making this video. And with that, I hope this video will help you first in understanding the NSF Water Quality Index, and also in guiding you in how to do the calculation part. And I hope this video will help you in many ways. So I request you to please help my channel prosper by subscribing, and also your comments and like are always appreciated. Thank you once again, and God bless.